Welcome everybody to the next session of Oracle Real Application Clusters Office Hours. I'm Anil Nair. If you heard me or joined last month's Office Hours, you would remember that we covered a lot of topics over a whole range of questions. This time I got about 12 questions up front, so this is good. So again, I'm Anil Nair. I'm the Principal Product Manager for Oracle Real Application Clusters. And I'm joined by Ian Cookson, who's also going to be helping me with manning the chat while I talk about it. And Ian is the Product Manager for Clusterware. So between us, we should be able to answer all of your questions. So without further ado, let me just give you a second in case you want to take down some of the ways that you can reach us. That's the Twitter addresses, LinkedIn, or and if you want to look at my older presentations, that's my SlideShare location. And again, as usual, I always recommend that you send the questions for the next office hour, as soon as possible, so I can create slides on that, rather than just answering you, without any visuals. The visuals help in understanding or explaining the issue. So let's jump to the first question that was asked, and that was, how is buffer cache managed in RAC? What is DRM? So these were the two questions that I kind of put together into one, and essentially, this came to me late yesterday night. So if you see any, color combinations or something on the slides not up to mark, it's just because I had very less time. And again, this is why I say, please send me the questions you have a bit earlier so I can spend some time doing this. So buffer cache management in RAC, as the picture shows there, it's not much different than what you would see in a single instance. You have the same components: the buffer cache, the shared pool, in memory, and other miscellaneous what we call areas. So they all compose the SGA. And if you look at it, pretty much in a 4-node rack cluster, you got the same number of things. And I obviously want to point out that node number 2 or node number 3 could have more memory, which means you could have more SGA, more buffer cache, and so you could have a situation where there are different memory capacities on these servers, so you could have different SGAs. So what is different, in RAC is we have some additional components to manage the buffer cache. Why is that? Well, as we know in RAC, a session could connect to node 3, and it might require a block that might be cached in node 1's buffer cache. You do not have to change anything, but you definitely need to know that it doesn't matter where your blocks are, we will get it for you. And not only that we'll get it for you, we'll get it for you for your timeline. And I'll talk about that a little bit in the next slide. So this is what I'm trying to explain here. So I just took out the node so that I can have a little bit more space here. So if you consider this your total SGA, and these are the blocks, and I kind of color coded them. Hopefully, it looks different in your there is some there's brown here, there's gray, black here, so you can see that that's meant to depict that these are blocks which are cached on this node. These are the masters for this block. Now, what does a master mean? Essentially, a master is the guy who would know everything about the block that it is taking care of. So just to go over it once again, every buffer would have a master, which could be in the same instance or could be in some other instance. So for example, this guy's master, which is brown, could be node 4, node 2, or node 1. And master knows everything about that buffer. So when you keep updating, deleting records, and the buffer cache is updated, we actually know what's going on with that. So every buffer updates, buffer changes is notified. You could have one master for multiple buffers. So it's not like this guy, there's a 1:1 correspondence. This guy could be taking care of X number of buffers, so it's fine. And again, as I've been saying this multiple times, do not require any manual intervention or setting. Okay. Ian, I think it's you. Can you not type that loud? Sorry, please.
Sorry.
Sorry. Okay. So that's one thing. Now, how does this all work? So here's, let's understand what we call cache fusion. So in cache fusion, what happens is you would have, let's say, a user, let's say, who's coming in to do a query, and he goes to node 4. Now, remember, in our example case, the buffer that it wants is in node 1. So the first thing that it does is, it has to figure out who is the master, and the master could be in node 2. So at worst to worst case, we will have maximum three-way communication, which means the user connects to node 4. There is a message sent to find out where it is latest. Now it found out it's on 1. Then there's a message to find out, get the access from the master, and then it can do or take that block. If the grant is given, it can do whatever it wants. Again, these are a lot more details, and because of the questions that came up, like I got about 6 questions talking about the same thing. So all in all, this is just an explanation of what happens below the covers. Again, I keep repeating this. You do not have to do anything. Once you set cluster database equal to true, we will spread this buffers across the different nodes we have, instances that we have, and that's how we can get some of these automation built in. So you don't have to do anything. You just have to define your services, and I'll go into that aspect. There is this component called DLM, because somebody asked me that. What is a DLM? So DLM, kind of at a very high level, I've just put it there. Again, it's an internal concept. It kind of manages buffer cache and master relationship. So when there is a need for a block, or there is a need to grant the user to change that block, what we call as a permission or a grant, it takes care of all that. Again, like I said, this is done automatically. You don't have to do anything. Different queries, depending on where it is, would be able to take care of all the advantages of that DLM optimizations to reach the block that it wants. Now, again, let's get into the part of what is a DRM, right? Now, we talked about worst case scenario. You have 3 messages, right? Now, again, the goal is to ensure that we reduce these the messages. Now, again, these messages are latency sensitive, so we try to move the mastership where the buffer is frequently accessed from. So there are 2 times when we do this. So remember, when all the nodes are down and you start up all the instances and the nodes, so you start up the nodes and the instances start up. During the buffer cache being warmed up, we ensure that the master is moved to the node where most of this modification have occurred. And I have another slide which goes into a little bit more details on that. And let's say your load has changed over the period of time. So anytime these load changes, we kind of try to move this via what we call as dynamic resource mastering. During runtime, we try to move some of this master to the instance or the node where that buffer is frequently accessed. Now, there are some numbers there. We don't have to get into it. Like, what happens if only node 2 and 3 get it? Then where does the master come? And if 2 gets it a little bit more times than 3. So there are some numbers there. Again, these are internal implementation details. But it's very important to know that we, when we say we, Cache Fusion tries to move this, the mastership of the blocks as close as possible to the block itself. So we don't have to incur the cost of what we call of sending an additional message to other node. So how does this help, right? And this is something last time after I presented it at a very higher level, I got some questions about this saying, Anil, you talked about this optimization, but I didn't kind of understand it. Now, if you remember, or if you recall the way that the blocks are spread out, and you think it in this concept of how this works on a pluggable database or on different services which are not on all the nodes. Now, take this example here. You have 2 nodes, node A and node B. and you have this different PDBs. And now the color is intended to depict that the same PDB is not open on all the nodes. So in the past, before 12.2, we used to send these messages at the instance level, not at kind of the PDB level. So now, because of these optimizations, we are now able to send messages only to the nodes or between the nodes which are started in that between the instances where the services are offered. What does that mean? So earlier, if you see, we are sending them messages all over. Now we are kind of have a focused one. So this is important because of two reasons. One, obviously, the lesser messages we send, the better. So this is one thing. And second thing is, if this guy goes down for any reason, if the PDB does not offer its services on this node, then this PDB can kind of continue without being affected by what happens on the other node. Now, this is a very simple case of two node. You can easily see what happens in a four node scenario. What I like to highlight is it's kind of prevents noisy neighbors from affecting others with unnecessary chatter. To explain that, essentially, if let's say this guy is very, very busy and it is sending messages to other nodes, then the guys or the node where that service is not offered does not get affected by this, what we call as noisy neighbor. Ian, by the way, if there is any questions regarding this as I'm talking through, please feel free to interrupt me.
Will do.
Okay, thanks. Again, the second aspect of how this helps us is this what we call as isolation. Now, like I said earlier, in this case, if you have a two-node cluster where services are offered for, like, the red PDB, the gray PDB, and the yellow PDB, these guys are not affected if this whole node goes down or this instance goes down. So they're kind of isolated. Now, again, this is a simple example with two nodes. You can easily extrapolate to four nodes and see if you have the red being offered in node 1 and 3 and node 2 goes down, doesn't matter because these guys can continue their work. Okay, that's the animation to show the same. The final thing is, I talked a bit about this, and I'm going to jump to the slide first so that you can understand what I'm saying. And this is the slide that I want to show you about. And this is the fact that optimizations during startup ensure that the master is on the instance where most modifications occur. So how does that work? Well, what we do, and as quickly as I can get to the slide so you can have the visual, essentially, we now store what we call as the relationship between which service causes which buffer to be loaded in the cache. So let's say you have a couple of services. You have sales service and your accounting service. When you access some table via sales service, the blocks that you access would be the relationship between the sales and the table would be stored in the data dictionary. This information is persisted in the database, and so when we restart, we could actually use this information to ensure that the master of those blocks are co-located with the buffers themselves. Okay. So hopefully that gives you very high-level information of what is DRM, what is DLM, and what is buffer cache management. I would say the only thing to take away from this as a DBA is, you do not have to worry about where the blocks are going to be mastered. What you've got to be planning for is how to create your services. How do you make sure that in your 2-node, 3-node, 4-node rack cluster, how do you distribute the services so you get your optimal performance that is based on your business requirements? Okay. Oh, that's another thing that by the way, I forgot to point out. Now, the other advantage of this feature is that since we now know which blocks and which services are related, in case there's a planned downtime, for singleton services, we can actually pre-warm the cache. What that means is, let's say you're connected to node 2 and all your sales table and the buffer cache is populated with whatever services, whatever users connect using the sales service. Then in anticipation of, let's say you want to do a patch on something on node B, you could actually pre-warm the cache so that when your users connect to node A and work, they don't have to go through physical reads, because the buffer cache on node B, we have attempted to be pre-warmed on node 1 or node A. Okay. Again, taking some of the advantages of this, we have introduced in 12.2 what we call as an LMS, consistent read serve, a slave. Excuse me. So what is that? It again helps mitigate performance outliers. What that means is, let's again go back to this slide deck, this image, so you can better understand it. So remember that if a node, if a session is trying to connect to node 4 and it wants a block which is on node 1, sometimes this block may be in a different SCN, and the query may require it at a different SCN time. So what happens is, below the covers, is we try to apply undo to this block so that we can give an image of this block to the user what that he actually wants. Now, you might think, okay, that's not so hard, but some of the times, some query might come in and require a block change that has been way in the past. That means the processes, that the cache fusion is actually waiting and on applying this. The specific process is LMS, that we call it, and LMS gets busy trying to get this block to a SCN that the user wants. Since LMS is generally going to work on a lot of blocks, if it gets stuck on a particular block, it takes the other guys get queued up. So what we have done is, if we find that, let's say, he needs to go through all these blocks in a sequence, then what happens is LMS looks at a particular block and says, hey, I need to apply a lot of undo to this guy. I'm going to delegate it to one of my LMS CR thread, and I'm going to go continue working on the other guys. When this LMS CR thread is done, it will point that out or send that block to the user, so nobody has to wait. And yet again, I want to highlight that you do not have to do anything special to make that change. That is automatically done in 12.2 for you. So as I said, LMS would just automatically do it without any changes coming from you. And the number, that how much undo to be applied, is automatically and dynamically calculated. And by default, we spawn one slave, and additional slaves are spawned as needed. So hope that explains also the LMS CR slaves that I talked about last time. And I got about a couple of questions, because I guess I did not introduce the context and then explain how it optimizes it. So hopefully, now it's a bit more clearer. And again, please, your feedback is very welcome. It's kind of difficult to present to a large audience where I don't know if a DBA is new to Oracle or new to RAC. So kind of trying to ensure that there's enough for everybody. Again, moving on to this context of undo header table hash. Again, remember, whenever you have an OLTP, you're going to insert, update, delete a lot. And if that happens, or whenever we do it, there is things that has to be done under the covers. For example, when you insert, whether it's committed, whether other nodes have committed it. So there is a requirement to what we call lookup or synchronize with other nodes on some of these things. In 12.2, we have some optimizations, what we call as the undo header hash table. So what we have done is, on every node, we have a hash table, and that hash table is updated by everybody when they have their insert, update, committed. Once that commit is done, this hash table is used to look up these things. So that means we have to send lesser messages, and therefore we can be much faster. Now, how do you know whether you're getting affected by it? So if you are on 12.1 or older releases, not in 12.2, because this feature is automatically enabled, you would see a AWR report, which shows something like this. The keyword is, you see that we have a lot more weights on the undo header rather than the data block. In general, this typically means that we are doing a lot of work in looking up this information from the remote nodes. And once you're, with this feature is, in place, you would see this number, reduces drastically. Okay. And moving with the final one with 18C, because I briefly introduced scalable sequences, and there was a couple of questions on what is scalable sequence? Does it only affect OLTP or DSS? I kind of put some numbers here, information here. So sequences, essentially, everybody knows sequences. It's been a feature of Oracle RDBMS for a while. With RAC, customers definitely can use sequences, but what we have seen is that if you use sequences and if you have certain attributes defined for sequences, they can sometimes cause what we call index block contention. And I'll show you how it looks like. Again, in the AWR report, this is what you would look like. So you would see the top 5 8 events, you would see a lot of this index contentions. Okay. So you have to remember that this is nothing to do with rack specific, it's not a rack specific weight event, it is generic, but because in rack, you're actually doing OLTP on all the nodes, this might kind of get amplified. And this is the exact issue that we have tried to mitigate via this implementation called scalable sequences. So in 18C, and I know it's not available for a lot of you guys, but it's available for engineered systems, and I think it's going to be available on the cloud if it's not already there. There is this feature which essentially provides you a new option. So if you do the create a sequence or alter sequence, you have these options called extend, no scale. At a very simple level, scale is specified. When scale is, you specify a scale, an internal algorithm will use the instance ID and generate an offset number, and that offset number is added to the sequence. Now, all the features that I talked about so far, this is something you have to work or do manually. Why? Because people create sequences, and sometimes that sequence is tied very closely to the business logic. Like I want to have certain sequence number in a certain order, or certain data instances, or certain tables, or certain business users can only get a certain range of sequences. So what we have done is we have explained it. We can use it, but the choice is on a DBA. It is a manual thing that you have to do. And obviously, if you need to see, hey, what is this, my extent or something, then it's all, you got to look at user, all sequences, or whatever DBA sequences, which will show you those numbers. Okay. And again, that's the help for the create sequence, and you can see that I've highlighted the scale, extend, no scale options there. So with that, I've completed the buffer cache and how all those optimization help with the various things that I talked about. Again, like I said, hopefully if you have questions, feel free to send it to me. I can cover it in a bit more detail in the next one, or if you have something else that is, really bothering you, please let us know. We can try to help answer as much rack questions as we can. Ian, is there anything on the chat that talks about?
Yeah, there's a follow-up actually to just to review what you've covered. Basically, I think they would like to understand what happens, a sequence of events when a node fails, whether it's due to a network or a disk failure or whatever. So what are the sequence of events, and especially when we start considering the block management and buffer ownership masters?
Okay, great. That's a good question, actually. That's a good question. I have some slides. I'm just going to go to the slide deck. Luckily, I have some of those slides here. So this is easier. I have like 106 slides in the slide deck. So give me a couple of minutes to go there. Okay. There you go. All right. So what happens is we have this feature called or it's not a feature, it's actually a stage called reconfiguration, and there are various specific stages or sub-stages in reconfiguration. So regardless of if clusterware or the RDBMS, or if it's a manual thing by customer where they flipped off the power switch, regardless of what causes it, there are some high-level stages of reconfiguration. So if you look at the screen on the right, I start with the top one. There's a detection phase, there's an eviction phase. We got to elect a recovery master, and that recovery master will actually read the redo and apply the recovery. Okay. So these are the very, very high level stages. So obviously, as it says, detect means if somebody is evicted, we need to know, because how we will detect, it depends on what kind of issue occurred. Regardless how it is, let's say the clusterware component, CSS, or the agent, or the RDBMS components like the LMON or LMS will get notified that, hey, I can't send this message to this guy who was there a couple of seconds ago. And after a while, we would evict it. And once that eviction is done, we need to elect a person who's left in the node. So for example, if you have 4 nodes, let's say node 4 goes away, then out of the 1, 2, and 3 who are still in the cluster, they need to be elected. One of those guys would be elected the RM, what we call as a recovery master. And this is the guy whose SMON will get us lock and then try to read the redo, apply the recovery. The recovery is essentially automatic. And the recovery is to ensure that all the committed transactions are committed and all the uncommitted transactions are rolled back. And then, the node is up and open for business. So this is a very high level step. And since this question was asked, there is this concept of new concept called recovery buddy. We have this in 12.2. A recovery buddy attempts to reduce the reconfiguration time by optimizing some of the stages. What that means is we try to optimize certain steps. So in this case, detect is fine, we evict, but the rest of the stages we try to optimize. I'll explain that in a step here. So recovery buddy, again, is automatic. You don't have to do anything. But in this case, let's say you have a cluster called my cluster. We have 4 nodes. In this case, recovery buddy is something like this. Again, you don't have to map it. It's just very simple. You have instance ones to, recovery buddies in 4, 2, for instance, 2 recovery buddies in 1. What that means is there is a specific process or an area in the SGA that we allocate for storing this information. Now, what the optimization is actually 2-phase. One is if, let's say, instance 3 goes away, there doesn't need to be any vote to find out who's the next guy. It's recovery buddy 2, because this is the guy who's supposed to manage an instance 3's changes. So initial, this is so easy. And the second part is we don't have to also read the redo, because the redo is in this guy's cache or hash in a hash table. So we can just go and just focus on applying that. This makes it so much faster that between this specific feature and the service-oriented buffer cache feature, the recovery, the reconfiguration times has been really, really low in 12.2. And we have also worked a bit to make it even better numbers in 18. Again, better meaning lower numbers, okay? So hope that answers that question. Ian, anything, any follow-up on that, or I can go to the next question that was asked in the chat.
Sorry, I was on mute. Sorry,
No
Anil. Basically, another question that had come up was, oh, hold on, we got a follow-up coming here.
Kind of like blind here, but go ahead.
Yeah, I know you're flying blind. I'm not following. Hold on. I'm going to ask you a separate question, and then I'll get some details on this. So please come back to this. The question base is completely different topic. It is about the function of role separation and between the Oracle home and the grid home, and managing ASM. So running ASM CMD.
Okay.
In particular, in general.
Right. Do you want to just take the question for the role separation, since you are the master PM, or I can answer either way? That way you get a chance to talk.
No, we'll leave it for you. But okay. I think more pertinently, to understand the differentiation between the ASM instance and the Oracle instance.
Right. So again, this like a little bit of version specific question. So initially in 10G, we had 3 homes. We had what we call a GI home, we had an ASM home, and typically customers would have an RDBMS home. In 11G, we kind of moved them into one. What I mean by them is the GI home and the ASM home, what we call as the grid infrastructure now. So the grid infrastructure home is usually installed under a separate user. The idea being you would have one GI home or grid infrastructure home, and you will have multiple Oracle RAC homes, so that you could have multiple homes, multiple databases, and obviously if you use PDB option, you could have various PDBs with multi-tenant that you use. Again, it's a choice for customers what they want to use. You could have, for example, in certain cloud environments in Oracle Cloud, we have one GI home and one RAC home, and we recommend using multi-tenant because that is much easier to manage. The user separation is again because grid requires a bit more permission, so we have separated out. And grid and ASM, when I say grid, I obviously automatically also mean the ASM specific permissions. That's the way, and that's why it is separated. I have not seen customers use same for a while now. What I mean, same user and all that, it's again meant to be kept separate. You should really invest in ensuring that they are separate, so that all this auto management facilities that we have, like auto patch and all that, can work seamlessly, because a lot of those things are made with the intent that these guys are separated out. So that's the whole reason and the history why they were separated, and that's why it is actually a good practice to keep them separate. Okay.
Okay.
So, all right.
Yeah, go on.
Right, thanks. So I will go on to the next one. There was some question again about how many networks did Oracle RAC require? And I said, okay, so let me explain a bit about these guys. And there were some question about what is the meaning of some of the messages in the alert log that you see on their different environments. So I'll just go over a bit. Again, this is probably very basic for all the experienced DBAs out there. But I just thought I'll put it out there. You have all these different kinds of network and IP requirements and all that, kind of put all that together. Again, public is something that you will have for single instance. Virtual IP is there for a specific reason, and that's to ensure that your sessions can fail over very, very quickly. Private network is for the heartbeats and the cache fusion that we just talked about. ASM network is for using the ASM. Remember we have this new Flex ASM aspect. So this ASM network is used for the Flex ASM. We have what we call as SCAN or single client access network. Again, this is one per cluster. SCAN is a very interesting because remember this was there for a particular reason. And the reason being, anytime you add or delete nodes, the client SQLnet or TNS names.ora does not need to be updated, because you usually define them with one scan information. That way, regardless of how many nodes you have, you typically have all of those guys, all the users using only the scan definition. And at our end, but I mean, when I say our end, at the clusterware end, we will take care of which nodes of the cluster the scan will run on. And then there is this GNS. I'm not going to get into it much because it's optional. Well, almost. There is a certain implementation of what we call as cluster domain that may require it. So again, just to keep it simple, let's just say for this that it's optional. And the way it would look at when you do a if config -a is you would see this ETH0 with your IP address, and then you will have a bunch of other things. So this bunch of other what we call logical addresses is again automatically managed. You don't have to do anything. But this was actually an image that somebody sent me saying, "Hey, Anil, when I do if config, I see this 1,000 things. Why are you doing this? Why are you starting this?" Well, there is a reason for this. Like I said, some of this is because of the VIP. We put the VIP on the public IP, and this reason is if the interface goes down, we need to move the VIP to the other node so that the connections that are coming in do not experience like a network hang or timeout and wait. So essentially, this is for faster client failover. Again, in the private network, also there are some of these things. Again, just ETH1 is the private network. You would see we use our own HA or bonding solution. So you would see what we call as HAIP. Again, you do not have to do anything. We automatically do this for you. You just need to define what interface we need to be using, and we will create these additional things. Now, about the question regarding, hey, Anil, what is this entries in my alert log? I'm completely confused. I'm trying to introduce this thing called rack interprocess communication. Now, what is that? Well, remember in Cache Fusion, when we need to send a message, there has to be a protocol. And this protocol is what we are trying to get into. Now, obviously, we use UDP as the protocol, but there is some optimizations in what we call as the layer. Now, an IPC is an interprocess communication, and the new feature in 12.2 is this lightweight implementation. This lightweight implementation is NUMA-aware, which means that we now allocate resources and we align those resources to be NUMA-aware. Because if they are not, if you have a process running on a certain CPUs in a different NUMA zone and the resource for that is in some other zone, then we have to go over what we call as additional hops over the quick path link. So we need to make sure that we automatically, again, you don't have to, as a DBA, you don't have to do it, but these are some of the new features of that IPC. So if you start your RDBMS and you would look at the alert log, you would see some messages like this. Again, these are version specific. This I picked up from a 12.2 environment, and this is a non-engineered system on Linux. So you would see something like it says, hey, my cluster interconnect is using IPC, and this is IPC lightweight over UDP. Again, you don't have to be worried about what exactly it says, but don't be worried when it says something. Now, the worst thing that could happen here is if it says that I'm using some IP that is not supposed to be used. For example, if it's using the public IP or some other IP which you had not intended it to be used, okay? Now, Accelerator, obviously engineered system, it uses RDMA, and it, the specific thing what we call is XRC. You would see things like that in the alert log. So if you open a RDBMS instance, it will look something like this. It'll say Oracle RDS, and it'll say some protocol information. Lastly, I've got this many times in the external chats that ASM alert log would probably give you an error, something like ASM does not support IPC lightweight switching to whatever thing. You don't have to worry. The reason ASM does not use ASM IPC lightweight is its use is different. It does not have typically a lot of the cache fusion going on, because remember, ASM is just a metadata for the RDBMS or rack. It is not in the path, so it does not need to use that lightweight. There is no benefit of it, so we didn't. In fact, there is I filed a bug just to make sure we don't even put that warning to take away that warning. So soon it'll be gone if it's not already gone. Okay.
Anil?
Yep.
Just as a follow-up on your discussion about networks.
Right.
Which is great. But We want to talk a bit more about what the role of TAF and application continuity in that scenario in terms of the networks. You talked about failovers and notifications, and then how that might apply to reducing the downtime for patching or zero downtime patching.
Right. Okay. Good questions actually. So again, I may not have any slides on this because I wasn't planning on talking about it right now. So TAF is really something that we had for a long time, and it actually worked great for all the queries that you had. So select statements, we had a very easy way of failing over your queries. Works great, perfect. The problem though is that with TAF is it did not work much for insert updates. So I would recommend getting familiar with what we call as application continuity. Now, what happens in an application continuity? There are two areas here, and just to get the image, I'll just make sure although I don't have the right excuse me, specific slide for client failover, I'll kind of show you here. So there you go. So let's say this guy is trying to do an insert or update or delete now, although I have put here query for the benefit of failover. Let's say he's coming over and he's connected to node 4. A couple of things that could happen. This node could probably go down, or the instance could probably go down because of a planned downtime or unplanned downtime. And it could be in the middle of a query, insert, update, delete again, just to be clear, or it could be just, it's down during connect time. A couple of things as a DBA you can do. Obviously, you want to make sure that all these users are connected using services. Now, if you have a planned downtime, when you use services, you can give a timeout as an optional component to which your sessions or the sessions that are already running on that node will be transferred to other nodes. For example, let's say this node 4 has the service sales running, then stopping the sales service with a timeout will ensure that the service sales is no longer going to be able, or users are no longer going to be able to connect to node 4 with that sales service. So when it comes here, this guy will say no. He will, in his TNS names.ora, there will be other guys, other nodes which will be offering that service. He will go somewhere else. There is also this component of scan. Like I said, the scan listeners would talk to the database listeners, and there would be a notification for that guys also. So it's not just that he has to go back to that TNS all the time. Sometimes he might come in, and again, depending on what point of time the scan listeners know, he would say, oh, instead of sending him to 4, I'll send him to 1. And it's actually automatically done. Again, user do not have to do anything. We automatically do these things for you. Now, finally, let's say once this guy is down, this connection can continue on to these guys, the other nodes who are offering that service. This is very important. And this is why we always recommend that before you stop your instance, you want to make sure you move your services. Now, this is something that can be done as a part of the planned downtime. Or in certain cases, let's say, it is unplanned. If it's a singleton, it might automatically move to one of these guys, and again, all of these are taken care of. If it's not singleton and you have only one node running it, or two nodes, it's running on 2 nodes, then you might have to ensure manually that, oh, this service is very crucial and this one node is not enough to take it, so you might have to move it manually. Other than that, again, these are all very minor things to do and in context of planned or unplanned downtime. And the takeaway from this is 2 things. TAF is a bit older. You obviously can use it, but you might want to look at or invest some time in what we call as app continuity. And I'm sure you've heard this many times. Whenever you use rack, you always want to create additional services and connect via services so that you can utilize some of these things. So, using services will ensure that your queries can fail over faster. And like I mentioned earlier, the VIP, that will ensure that if a network is being interrupted or network is going down or it's down, these sessions can fail over faster to the other nodes. I guess, Ian, I explained that a bit because, again, without some kind of visual, it's a little bit hard, and I can try next time to come up and build something so, it's much easier to go through.
Yeah. I think, well, let's just ask. This came from one of the chat questions, and I think, as much as anything, I think the emphasis was on patching and impact there as well. But I think you've addressed it well. Right. Thank you very much.
Sure.
Good.
Sure. Oh yeah, and the patching aspect, I always tell this. GI patching is always rolling, and GI upgrades are always rolling. Dbas patching, the auto patch is always rolling. So, obviously, if they have configured their clients correctly, and if they have services, then boom, the patching is done in a staged fashion. So it goes from node 1, then to node 2, node 3, and therefore the instances the same way. The only exception being this Java issue. Again, there is a note for that. I don't remember it top of my head, but if somebody really needs that note, they can ping us. I have the Twitter and all that other details given, and I can always try to dig up that note number and send it to you. Okay. Any other questions, Ian?
Well, here's a general one. I think this would be a good one. Listener.aura. Okay. I bet you don't have a slide on this one either.
No, I don't.
But all the same, there's a difference between the way we configure listeners on a single instance database, right, mm-hmm, and on a rack database. So in a general sense, what are the purposes, and how do we configure it differently for rack?
Yes, good question, actually. So, I try to focus a bit in these sessions to show you what's different. And again, all of you must be tired of hearing it's automatic, it's automatic, it's automatic. But actually, the listener is configured as part of the database install, and the GI. So the listener aura is always in the GI home. So there is some entries there that we automatically create based on whatever information you put in the installation screens. For example, what is your VIP, or what is your public IP, and all that information. What's your scan IP? We put all of that information and create a listener.aura. The difference between a single instance and rack or GI specific installation is that the listener is maintained from the GI home. So you always want to check your GI home for any kind of changes or anything. But by default, we have everything there. You don't have to change anything. There are two init.aura parameters. Again, the agent takes care of this. Their agent is a component of the grid infrastructure, and the agent will update the local listener and the remote listener. So, at a customer level, you don't have to really change anything. Now, I know there are certain cases, like if you're using wallets, you got to make some changes. If you're going to do some of these things, yes, there are some things manually. But again, those only go to the listener.aura running in the GI home that you can, edit and make those changes. In general, very less things are changing in the in the listener.aura, or I would not even recommend having anything in the database home, and that that just leads to confusion. You make some change, you expect the changes to be reflected in listener services or listener status, and you would be very unhappy to know that that's not the place where to make those changes. You want to make those changes in the listener.aura in the GI home. Okay.
Sounds good.
Good. Good, good. We have probably only time for maximum one more question because we're getting to the top of the hour, I think, right? It's 3:54. Okay.
I don't think I have any more, but I think just maybe a good overview. Well, you covered off a lot of detail about cache fusion.
Right.
And you talked a bit about the PDBs and cache buffer optimizations that are newly introduced.
Mm-hmm.
I think just one, if you thought of one or maybe two statements about how best to manage this scenario, how to avoid too much of cache fusion traffic. How would you address that?
Right. That's a good
spot,
question.
because I'm sure it's not on your slides here.
Right.
But I know you're an expert.
Thank you. So very, very simply put, I talk about, a lot of times, again, things are automatically taken care of. I always talk about that. But there are a couple of things that DBAs can do to ensure that you're, having peak or optimal performance, right? One is the Aura check that I keep recommending. Aura checks your network layer specifically and ensures that it's things that are supposed to be set are set. Like, for example, UDP receive, buff cache and all those things. The jumbo frames, if they're set up, things like that. We check for that. The reason being, all of this messaging and all that is very sensitive to latency. So the faster these messages can go, the better. If you change workloads, because of the optimizations we have, there is certain time until that threshold is hit, until which we will, send the remote messages. But typically, if you, look at your AWR reports, after it's been running for a certain period of time, you would see very less of these messages going across. We would try as much as we can to move some of these things in, so you don't have to worry. But again, my point being, check with Aura Check to ensure that your network is correctly set. If, by the way, you have more capacity, like if you have additional network cards, networks, I did mention that at 12, we have this new features, what we call as, HAIP. So we can utilize more and more of these networks. So you could define multiple private networks, so we can send these things faster to the other side. We also talked about UDP, and then we talked about the RDS with Exadata. Again, with Exadata, these things are way, way, way too fast. So again, these are, first of all, we have optimized the number of messages. Second of all, depending on engineered systems or the generic systems, these networks have a wide pipe with low latency. These are getting very common. So generally, they don't have to be, making any changes there. The most common problem we have seen is people misconfiguring the network, people not setting UDP send receive buffer cache. UDP send receive cache. People not setting enough of sockets, or making sure the OS has enough resources to do these activities quickly. Other than that, I think they just have to make sure they create their services correctly, plan their application logic such that you have optimized use of rack. Again, this is optional. Again, I'm not saying you have to have that. You could have uniform access, and that's perfectly fine. But if you want to even do more than that, you can obviously do it. Again, I cannot stress the importance of running Aura Check periodically. After every OS patch, after every Oracle rack patch, you want to run it. That way you get some kind of sense of something is not set up correctly. Okay. I think with that, we should probably not take any question. I'll just take a minute to reiterate this again, that guys, if you want a certain topic to be covered, send us that information. We can spend some time creating slides. We can look at it in more detail. If you have any questions, concerns, timing, suggestions on how to make this better, this is the time. This is really your show. We are just running it for you, but you have to tell us what content you want, what are the things you want us to talk about. So please feel free to send us a message. The URL that you have, which you used to join this, there is a feedback page. You can send it to us, and again, we really value your feedback. Ian, you want to add anything else?
No, I think that was very well done, Anil. I think we're at basically the end of the questions that I've seen.
Sure.
I think you've done the cache fusion thing to death, and I encourage other people out there. If you have follow-up questions, please contact us, and we'd be happy to address them. Okay.
Perfect. Thank you, guys, and thank you all for again joining us. We will now, end this session, and I hope to see you in the next office hours for RAC, which is exactly in a month. Until then, goodbye, and have a good rest of your day.